Hello everyone, hopefully everyone can hear me okay. We still have a few people joining, but the majority of people are on, and in the interest of time we'll get started. Firstly, welcome and thank you for attending this webinar. This is our second in a series that we're running around performance testing. We're building on the webinar that we presented last time, which was an introduction and an overview, and today this session is focused around performance test environments. We're going to be running through the key components of a performance test environment. So that's understanding how to build a load testing platform to inject load from, but also how to build a performance test environment that is representative of your live environment. A good understanding of the various factors at play here will enable you to better plan your performance testing and also help you understand the limitations and risks of doing this in an environment that in all likelihood will have varying degrees of similarity to live. A little bit about me, I'm Ash Gawthorpe, one of the co-founding directors of Ten10. Today we have 30 minutes to run through this, so in the interest of time we will be going at quite a pace. This webinar will be available for download at a later date, and we will email you the link to that, so you will have the opportunity to revisit it and to review it again if you need to. If you have a question at any point, please ask a question in the questions window there on the right hand side, and we will endeavour to answer as many of these as we can at the end of this session, and any we can't answer we'll reply to you directly. So first of all, let's just think about an environment that we need in order to undertake performance testing. As a starting point, you need to think logically about your environment. What do you need in order to test? Now, these are the same questions that we'd be asking at this point as if we were building a functional test environment. So the questions include, what are the individual components? And I recommend that the easiest way to do this is to draw these up on the board as boxes and arrows with names in those boxes. What are the different internal systems that your system communicates with? Again, draw these up as boxes with arrows showing information flow backwards and forwards. Then think about what third parties does your system need to talk to in order to operate. So those external parties that we commonly see are things such as payment providers, other internal systems, postcode lookup systems, and anything really that uses an external API to the outside world, which your system needs in order to work end to end. Also, we need to think about what data do you need. So what data is required in order for the system to function? If you're looking at a functional test environment, then you need to consider how to set this data up, how that data is manipulated, changed, or destroyed by the tests that you're running, how to clear it down afterwards at the end, and how to restore it so you're able to rerun a test. This is exactly the same in performance test, just the volumes involved are so much greater. Now, these questions will have been answered if you have a functional test environment for the system. If you're lucky, they may all be clearly defined in documentation that's maintained and crucially is up to date. Often you may find that there is documentation around this that existed at a point way back and hasn't been updated. And sometimes you find there may be no documentation, and it involves you speaking with people across different teams and potentially across different companies, different suppliers, and potentially even customers as well. But essentially what you're building here is the logical architecture, the sort of the big picture of what it is that you need and what components need to be included in your performance test environment. Now that we have that logical view, we need to drill into this a little bit more. We need to ask ourselves some more questions. So now we're becoming more concerned with the physical architecture of the system. So what it means in practice that's used to actually implement those components that we defined on the previous slide. So what does production look like? Now, this is assuming that the production environment exists. If it's a new system and it doesn't exist, then speaking with the architecture teams that are there designing the production system to understand what it will look like is key. Where is it hosted? So this is a really important point. Is it hosted on-prem, on premises? Is it hosted in the cloud? Or is it a hybrid system using a combination of both? So this is very important as it has a huge impact on how you're going to build out your performance test environment and the cost of building out that environment. The other question to ask yourself is, if it's on-prem, is it physical or is it virtual? Or in fact, is it both? It could be a combination of the two. So you now need to start thinking about the hardware, so the size and the spec of servers. Now this applies whether it's on-prem and physical, virtual, or whether it's cloud-based. We need to start thinking about the network infrastructure. This includes internal networking specs and also any internet-facing infrastructure that exists, so firewalls, load balancers. You need to think about storage. So whether you have a SAN, storage detached network, or whether you have other forms of storage, or it might actually be local disk on the servers as well. All this needs to be considered. You need to think about scaling. So whether if it's cloud-based or on-prem and virtualized, it may be that your system, various tiers in your system, are able to dynamically scale horizontally by adding more servers to a particular tier if the load demands it. And then also, finally, we need to think about data configuration and sizing of test data. Let's just dive into each one of those in a little bit more detail. First thing to consider are the servers. So we need to think about the size and the specification of those servers, regardless of whether it's on-premise or whether it's cloud-based. We need to think about the number of cores, the speed of those cores, the type of cores, and by core I mean processor. We need to think about the amount of memory on each server and the speed of memory used. If there are local disks attached, we need to think about what type of disks they are. Are they spinning disks? And if they are, we need to know the speed of them. Is it solid state storage? And in terms of software, we need to think about the operating system that's on there, the version of operating system that's on there, any base software to do with security products or antivirus software. And we also need to understand sort of the update schedule. So whether these are auto-updated based on patches that are deployed, or whether they are controlled and deployed by a team within the organization. One point here, I'm assuming that most people are using standard server architecture, by which I mean Intel or AMD hardware with Linux or Windows as the operating system. If you have something else, particularly mainframe technology, then that makes things a little bit more complicated, but there are approaches and techniques that we can consider, which we'll come back to a little bit later on in order to look at that. Next, we need to think about the network infrastructure. So there's a number of parts to this. So we need to think about the storage tier and what that looks like. So whether there's a SAN, a storage area network, whether there's network attached storage, the size, speed, and spec of that storage, the general networking components between the servers. We need to think about the speed of those networks, and also any other network infrastructure that might be involved there as well. Often that means that there may be segregated networks. You may have different traffic traveling down different VLANs. That might be segregated for security reasons. You may, for example, have a section of the system which has a boundary for PCI compliance around it, that's storing sort of user credit card information and that kind of thing. So that needs to be considered as well. And then finally, you need to think about the internet-facing and sort of top-level infrastructure. So load balancers, internet-facing firewalls. You also need to think about the monitoring tools you're going to be using in that environment. Ideally, you want to be using the same monitoring in performance tests that you're using in production. What that allows you to do is, within that tool, you'll be able to set thresholds and various alerts, which, when those thresholds are breached, maybe a text message will be sent or an email will be sent to a particular individual or to a group. What you're able to do is you're able to see from the performance testing results at what point the system degrades, and you're able to set those thresholds and alerts accordingly. You may find when you're doing your testing that if something starts to happen, you're able to take evasive action, essentially, which saves the system, or which restores the system and allows it to continue running without there being a catastrophic failure. That's really valuable information, and if you're using the same tool, you'll be able to take that same alerting that same sort of early warning system essentially, and deploy that into live, which is then invaluable for the app support teams that are whose day job is then monitoring live and ensuring that that system stays up and stays available. One other point to consider, some, not all, but some monitoring tools, particularly those that have that sort of agent model where you have to deploy a component on each server in order for it to capture the resource utilization information. Sometimes those agents can actually add load themselves, and that's really something that you need to be watch and you need to be wary of. You should now be building up a picture of what that physical architecture looks like. This is really a shopping list, and the next step is to take that shopping list to whoever in the organization holds the purse strings to establish the appetite to spend the kind of money required in order to do this on a non-production system. If you have a large, complex on-premise environment, then it could be very, very expensive. If it's all cloud-based on an infrastructure as a service platform like AWS or Azure, then it's going to cost a lot less, and you're not going to need to sink any initial capital into it to build the environment in the first place. One potential option here is that if there is a DR or disaster recovery environment, then it may be possible to re-provision that for the purpose of performance testing. You're now building a picture of the type of environment that you can build, and they largely fall into two categories. Representative environments are very live-like. They have the same infrastructure spec as live, with the same configuration, the same software deployed, the same monitoring, the same background check, the same background jobs, the same setup, or at least as close as that can possibly be to live. Most people don't have this. Most people end up cutting a few corners for economic or for practical considerations. In actual fact, some people end up having to cut off all the corners and cut out the middle as well in order to build an environment that they have budget for and they can secure budget for, essentially. The key point here, though, is that the further you deviate from the spec of the live environment, the greater the risk that the results you see in your performance test and your performance testing environment will not be representative of live. However, it is a risk, but then I guess risk is really what testing is all about, identifying those risks, evaluating the likelihood and impact of them occurring and mitigating against them. So if you don't have an environment which is a true copy of live, then all is not lost. As an absolute minimum, what you can do is you can run performance tests in that environment to determine a benchmark. And what do we mean by benchmarking? Benchmarking allows us to run a performance test and to get a gauge of how well it performs, and then to be able to see as you change the software, as you change the configuration within that environment, you're able to see if it improves or regresses that performance as those changes are made. So this can be very powerful as it allows you to test with a much smaller and cheaper environment earlier in that development lifecycle. You'll often hear the term shift left talked about. So what we're doing here is, in terms of the actual planning and when we execute the testing, we are shifting left that performance test and some of the other non-functional testing and taking it from a place where you're running a big performance test at the end fairly irregularly with lots of changes going in before you do that performance test, to a point where you're able to run that performance test on that smaller benchmarking environment far more frequently or even continuously as part of the CI build process that you might have, to give you those insights into those changes in performance far earlier, and so therefore you're able to fix them far earlier as well. So really at this point there's a bit of a trade-off required. So the question is, how much scaling back can you get away with whilst maintaining a useful performance test environment? Now in practice, this really is as much of an art as it is a science. There's a number of key considerations here. If the tier of infrastructure that you're looking at uses multiple servers in live, then you should have at least two. You don't have to have the full number that there's there in live, but if it is load balanced, you need to ensure that you have load balancing in that environment too. The same goes for segregated networks and any sort of security that's applied there. You should try to replicate that as much as you can. And load balancing just generally warrants very close attention. When we do see problems in environments, it's often when you go from it's been tested in a simple functional test environment through to it coming into what we'll call a grown-up sort of production-like environment here. Chances are you will find problems, and those problems will need to be resolved in order to make the system work functionally in that grown-up environment. So the next step at this point is working out how representative the results obtained from our non-representative environment actually are, and how we can apply scaling factors to the results to try and predict how the results we obtain in perf tests will translate into the results obtained in production. Firstly, a word of caution. Systems generally don't scale linearly. So for example, if you have a web tier there with let's say 4 nodes in performance testing and 8 nodes in production, you shouldn't assume that it will be able to service twice the number of user requests or take twice the amount of load in prod, as you can see in perf test. You do need to come up with something though to be able to give a view of how it will perform in live. But again, this part is as much an art as it is a science. So part of this understanding is working out how the system does scale within the constraints of what you have in performance tests. So if we take that example before, if you have 4 servers in a web tier, you should also perform the load testing in that environment with 1 server, 2 servers, 3 servers, or all 4 servers, and compare the results. Now, I know I mentioned before about if you have a load balanced environment, you shouldn't be running it with 1 server, and you should certainly have more than 1 in there. But running it with just 1 server in play there, it is useful to see how the system performs and scales. We've come across scenarios before now in the past where we've had 8 nodes in a particular tier and the system performs better with 1 node than it does with 8 of them. Now clearly that's not the way it was intended or designed to work, and so at that point there's some work to do to investigate what's going on and to see what's happening. But by running 1, 2, 3 and 4 servers in that environment, you're then able to see how it does scale, and so that will then give you some sort of insight into sort of how it will scale with 8 there in that tier. Now, if the system is live and you have results from live, you can start to create the profile that you build, which is actually going to be the subject to the next webinar, how you create those load profiles. But you can take a profile from live and you can run that through your performance test environment, and you can observe the results in performance test to see how that compares and see how hot everything is running and how long everything is taking in comparison to what you saw in live. You can then use this to drive your scaling calculations. If it's not live yet, then once you are, the most important thing is that you need to fold back in the results from live to compare this to the results that you're seeing in load testing. This needs to be done regularly, and it's good practice to proactively do this. That's a much better option rather than waiting, rather than running with the same load profiles, assuming that everything's fine in the same configuration, and then finding a problem in production and you trying to repeat that in your performance test at that point. I should also make the point that this section that we're talking about now is very, very closely aligned to a white paper that we wrote about performance testing environments, and specifically about performance testing in non-representative environments. So this white paper is available for download from our website for free. There will be an email with a link to the white paper coming out to you at some point either today or in the next couple of days. Now this white paper doesn't go into a lot more detail on what we're discussing today, but also covers a number of areas that we don't have time to cover. So things like CDNs, content delivery networks, where commonly deployed static assets aren't served by your system, but by a provider that has servers all over the world. So if a user connects from a different geography, they're downloading those static assets from a server which is close to them rather than from your data center. Caching strategies for content, how to optimize that and ensure that's configured as live, and also there's quite a bit in there about database configuration, so query structure and optimization, indexing, clustering, and sort of row and table locking, and the impact that that can have. Now I want to talk about producing representative datasets for performance testing. So there are three main challenges to consider here. So the first one is producing enough data for the test. Now this is both for a point in time now, but also for a point in the future. If, for example, your prod database is a terabyte and you're growing at 200 gigabytes per year and you need to demonstrate it will perform in T plus 5 years, how do you manage to magic another terabyte of data into existence so you're able to test it with 2 terabytes of data? The second point is around producing representative data. The structure and complexity of that data needs to be maintained. Be wary of copying data. If you just say you have your terabyte for an example there and you just copy the same copy of the data for the additional terabyte, this can have an impact in terms of the way the database works behind the bonnet, in terms of how it optimizes those queries and how it caches things. The other point here, you need to ensure that that data works at scale. There's nothing more frustrating than getting halfway through a performance test and finding that the data that you have or that you've fabricated doesn't work, i.e. the application just starts throwing errors all over the place and you find yourself having to abort the test. It's very, very important that you check the integrity of that data and ensure that it works. Finally, on this point, you need to make sure that any data that you have in there syncs up with the other third parties that you have and that your system is connecting to. So for example, if you have a user registered and you are buying something on behalf of that user, the credit card information needs to tally with what the payment provider is expecting to see in order to produce a successful transaction. The third point is around making it repeatable. Now this can sometimes be a little tricky. You may find that the data that you have in that system may be time sensitive in one way or another. So this means that in order to keep using that data, it needs to be updated. Testing can often be destructive or can modify the data. So after you've run a test, the data will no longer be in a state for you to run that test again. And so a very important point to consider here is how do you run multiple tests? And you really have two options. After the test, you're either able to restore back to a point in time, so just restore the database and all the associated other data back to a point. Sometimes that can't be done, in which case you need to repeat the same process that you deployed before to create the data, to create more data for the additional tests. Now, we use that method as well if required, but the important point there to make sure is that at the end of the test, you'll find that the data set grows rapidly. You will need to purge that at some point. I now just want to briefly consider those third-party services that we discussed earlier. Just to be clear, this is quite a large point, and in actual fact we have a webinar dedicated to stubbing, mocking, service virtualization of third-party services scheduled a little bit further down the line. But for today, really just to make the point that there are a number of options open to you. So option one, you're able to de-scope those third-party services from the testing entirely. I don't recommend that, particularly if the activity performed by that third-party service is very important to the application. Alternatively, you can add code into your app to turn the response around internally without it even going out to that third party. But again, that introduces risk. And then the third point is service virtualization, or stubbing or mocking the interactions with those third parties. So in effect, what you're doing here is you're taking that API to that third party service, and rather than having that request being turned around by the third party service itself, you're creating something which is an equivalent of it, which then allows you to control that and to control its behavior as well. So in terms of the questions that you need to ask yourself around service virtualization, it's a little bit like what we discussed last time around selecting the performance test tool, really. So the first question is, what protocol is used? If it's HTTP or HTTPS, and hopefully it is, then that becomes a lot easier. If it's a sort of bespoke binary protocol that's used, and that becomes a lot harder. How complex is the system to be virtualized? It may be that there's a very complex API there that would need to be simulated, but the next point's equally important. How much of it is actually used? Bear in mind that when you're doing a performance test, you're not doing the full functional test coverage of the interaction with that third-party API. If you are, for instance, simulating a user transaction where you're buying an item on an e-commerce website, really all you want to do is fire in the credit card details and the transaction amount and have that service respond with a, yep, that's fine, that's paid for, kind of happy path response. And if that service is critical, does it have its own non-functional requirements? It may be that the service does, maybe there's an SLA in place, and then this allows you to simulate what would happen if that third party is performing on the end of it, what's its acceptable performance within the SLA, and you can see the impact that that has on your system. And finally, just to reiterate that point, that we often can get away with the happy path or the very standard, very simple interactions with that third party. Let's take a second to think about the load injection platform itself. So this is the collection of servers and infrastructure which you're using to actually generate the load from. So it has the performance test tool deployed on there. It has a load profile with running the scripts. It has the user data. It has everything you need in order to run the test. So the first choice you need to make is whether you want to run that on-premise or whether you want to run that in the cloud through AWS or Azure or a similar service. Our advice is to use cloud-based where possible. This does open up more options. There are a number of scenarios where this wouldn't work. So for example, if the environment is not available to the internet for one reason or another, and you're not able to access it from the net, then you're not going to be able to use a cloud-based approach. If you are able to use that cloud-based approach, then what that allows you to do, it allows you to test that top level internet-facing network infrastructure that we discussed before that can often cause a number of problems. So the firewalls, load balancers, etc., etc. By doing it in this way, you are truly testing all of those components. Sometimes you do need to be wary if you're testing from an IaaS provider in terms of how the firewall interprets that load. If it thinks there's a lot of load coming from a sort of a fairly fixed IP range, and it may interpret that as a denial of service attack, and so it may start rejecting traffic from that. One of the points is that if you are testing a system under test which is deployed in, say, AWS, then be very wary of load testing it from AWS as well, because there are all kinds of optimized routes that Amazon use, which mean that whilst it would perform very quickly, it isn't as representative because you're not truly going out over the public internet necessarily. One more very important point. These services are great in that you're able to spin up as much infrastructure largely as you need, but what's very, very important is that you remember to shut down those servers at the end. Otherwise, you start building very, very large builds very quickly. And finally, depending on the type of performance test tool you're using, if you're using them in the cloud, you do need to be wary of licensing according to how many servers you're using and whether you're able to deploy that licensing on those cloud-based servers. That's everything I wanted to cover today. I appreciate there's quite a lot of detail here, but hopefully that should provide you with some useful information and an overarching approach to get you started around building a performance test environment, and hopefully make you aware of some of the pitfalls so you can see them coming and hopefully avoid them. As I mentioned before, it's worthwhile reading that associated white paper that we produced, which does go into a little bit more depth, and you will receive a link around that. And also that this webinar will be available for download. And so if you do want to revisit it or look at it again, you're very, very welcome to do so. And we do have about one minute left or so, just to have a quick look at some of the questions that we've received. There are a few. We only really have time, I think, for one. Looking at the just looking at the clock here. So, question around service virtualization. Any tool recommendations for service virtualization? The The answer is yes. There are a few. There are commercial tools, there are open source tools, but the ones to choose and your choice of tool really comes down to the complexity and the number of interfaces that you need to virtualize, and also the underlying technology that they're implemented in. So if it is HTTP, there's a number of open source ones, so Wiremock, Hoverfly, that work really well. If you have something that's much more complicated, then there are commercial tools from the likes of IBM with their Rational Test Virtualization Server, SmartBear, Service V. There are other tools as well, but they are significantly more expensive. As I mentioned, we will be doing a webinar on that in a few weeks' time, so watch this space on that and you'll receive an invite for that one as well. So really just to say thank you very, very much for attending. There have been a couple more questions. We will answer these separately and individually to people. If you do have any more questions, feel free to fire those into us. And just to say, well, thank you very much for attending this webinar today. I hope it's been useful. We will be running a number of these around performance testing, and then we're probably going to expand them into other sections as well. If you have any thoughts or any suggestions around maybe what you'd like us to cover next time or in a future webinar, that would be very well received as well. So enjoy the rest of your day, and thank you very much for attending today. Thank you.